Okay, so the skill of factorising. And the very first thing is very often the most forgotten thing, and it's simply that common factor. 5 goes in everything, or 6 goes in everything. Be amazed how often people forget to pull that out. Then the number of terms the algebraic expression has gives you a clue on the technique to use. So if you've got 2 terms, is it the difference of 2 squares? There's a common sort of factorisation. Sum and difference of 2 cubes. You may or may not have seen that one before, but we'll look at that today. If there's 3 terms, well, the classic 3 terms is, as the name suggests, trinomial. And when we're talking about polynomials with 3 terms, that's our classic quadratic usually, because you'll have an x squared term, an x term, and a constant term. So is it a quadratic? 4 terms? Then grouping in pairs usually is a technique we'll try there. So some quick examples. First of all, common factor. Now, I don't put this example up to say this is hard. Hopefully it won't blow your mind. But basically to highlight, factorising simply means dividing by the common factor. But instead of dividing and it disappears, so if I said to you, divide 5x plus x squared by x, you'd say, oh, that's 5 plus x. So that common factor disappears. Well, the difference with factorisation is it doesn't disappear. We put it out the front and write it as a multiplication. So ax plus bx, ooh, that's tricky. Of course, has x in common, and we're breaking it down into factors. It actually is no different to what you did back in year 7, maybe even earlier. Remember how you used to write numbers as products of prime factors? That's exactly what you're doing here. The difference is it's algebra. So with prime factors, you broke it down to the smallest number that couldn't be broken down, the prime number. You know, you got it down to a factor of 3. Couldn't break that number down anymore because it's prime. And so, yes, there was a factor of 3 and so on. So it's exactly the same. We break it down. I'll take the x out, but the x is unknown, so I don't know how to break that up. So we leave it as x. And then the a and the b also, we don't know what they are, so we'll leave it like that. And as I was just saying, the classic mistake is people will notice the x, but forget, oh, hang on, 5 goes into both of those as well. So we have 5x, x minus 2. Common factor, 4 terms. Well, grouping in pairs really is just common factors, usually. Because you look at it and you go, oh, what's in common? Oh, m's in 2 of them. Oh, damn, it's only in 2. X, oh, it's only in 2. Y, oh, it's only in 2. And then, oh, it's only in 2. Doesn't matter which letter I pick, it's not in all of them. And so you go, well, let's treat them in pairs. It doesn't really matter which pair you pick, you just give it a go, and if it works, fantastic. If not, we try a different pair. So I guess logically we look at the first one. Oh, look, it's got x as a common factor. Now you'll notice in the second one, because the idea being what we're left with, that second factor there of m minus n, I want that to be the same in both. So in order to do that, I pulled out a negative common factor rather than a positive. So if you notice in the parentheses, you've got the same pronumerals, but all the signs are different, well then you just pull out the negative, and then that'll change all the signs. And then you've got another common factor, because now I've got 2 terms, and they have a common factor of m minus n, and so there's the factorisation. M minus n, and I'm left with x minus y. Okay, difference of 2 squares. So it comes from the classic expansion of a minus b, a plus b, but going back the other way. 16x squared minus 1. All right. Well, I noticed 16x squared, that's 4x and so on. So if you notice the pattern, life becomes real easy. You see things 2 squares. Oh, hang on a sec. 3 is not a square. 75 is not a square, unless I start using surds, but that seems absurd. But of course, common factor. Always look for the common factor first. There is a common factor of 3, and when I pull that out, I have got a classic difference of 2 squares there. So always look for that common factor. There we go. Oh, hang on. 4 terms. Grouping in pairs. Oh yeah, still works. I've got a common factor of 5 in the first one. The second 2 pair, I can do by difference of 2 squares. And I end up with 5 outside of x minus y. And then with the difference of 2 squares, I've got x minus y, x plus y. They now have a common factor of x minus y. And, you know, again, if you ever get confused about what to write in that second parentheses, remember, all you're doing is dividing. So imagine you did a division, what would be left? If I divided by x minus y, I'd be left with 5 on that one, and I'd be left with plus x plus y for the second one. So there it is, 5 plus x plus y. Quadratic. Monics are usually the easiest, and it all comes from the idea of what adds together to give the middle term, what multiplies together. Because if I was to use the classic binomial expansion, its answer is x squared plus a plus bx plus ab. So that's basically what we're looking for. We're looking for two numbers, a and b. Adds together in the middle, multiplies together at the end. So alright, multiplies together to give 18, adds together to give 9. The things we're looking for, when it's multiplication, we know that positive times positive gives positive, positive times negative gives negative, negative times negative gives positive. So I've got a positive multiplication, it's either going to be two positives or two negatives, so that's when we go to the middle term, and it's going to be the same sign as the middle term. So it's going to be two positives. And the actual numbers, 18, 9, what's that? 6 and 3. 6 and 3. There's our numbers. Multiplies together 18, add together 9, 6 and 3. Doesn't have to be x, of course. Oh no, we can get real tricky in maths. We can use other letters as well. This time, it must be two negatives that multiply together, because the middle term's negative. Love it when they give us prime numbers, because there's only one combination you can use there. 3 and 1. Sure enough, 3 and 1 give us 4. So we have t minus 3, t minus 1. Uh-oh, two pronumerals. Doesn't matter. Don't let the y confuse you. The key is still the number. So what multiplies together to give 4y squared adds together to give minus 5y. Well, it's still going to be something y and something y, because when you multiply them together, you're going to get that y squared. So the number is the key. Multiply 4, add to give minus 5, it's got to be negative. So negative 4 and negative 1, but when I write it down, I don't write minus 4 minus 1, I now put the y in. So I've got x minus y, or 1y, x minus 4y. And that's terrific if it's monic, if that coefficient of x squared is 1. But what if it's not? Again, there's all sorts of different techniques. Probably the most common technique is the cross method. So the way most people have been shown, when you got your cross and work it out, it's probably one of the more popular ones. I actually like the splitting the middle method, which some of you may well have seen. But the reason I like it is because I don't have to change my logic to how I solved the other type. It's still looking for a combination of numbers. What multiplies together to give something, what adds together to give something. So what we do is splitting the middle. It's now 3x squared, not x squared. So I say, what multiplies together to give, but not negative 7? What we do is we end up multiplying the constant by the coefficient of x squared. So I'll say, what multiplies together to give negative 21 instead of negative 7? Still add together to give 4. All right, so this time we're multiplying to give a negative, so one's going to be a positive number, one's going to be a negative number. So basically I'm looking for two numbers where the difference is 4. If you add, well, not minus 7 and 3, but 7 and minus 3, you get positive 4. And what we do is we split the middle term into those two numbers. So instead of writing it as 4x, I've now got minus 3x and 7x, and it becomes a grouping in pairs question. And so the first two have a common factor of 3x, second two have a common factor of 7, there's a common factor of x minus 1, so there's our factorisation, x minus 1, 3x plus 7. So that's what we call splitting the middle. Let's do another one. So it multiplies together not to give negative 12, but negative 24. That would be 2 times negative 12. Again, it multiplies together to give a negative, so I'm looking for a positive and a negative number. But this time they're going to add to give negative 5, so I know the negative number is going to be the bigger number. 24, factors of 24, we're looking for a difference of 5. What goes with 24? 12 twos, no, that's no good. 6 fours, that's no good. What else is 24? I'm forgetting an obvious one, aren't I? 8 threes. Thank you. And there's a difference of 5. So we'll split the middle one into minus 8x plus 3x. And we can now group in pairs. Common factor of 2x, common factor of 3, leaves us with x minus 4 in both. So we get x minus 4, 2x plus 3. If you've never tried that splitting the middle technique, when it does come time to do the exercise, have a go using that method. If you still prefer to do the cross method, then by all means, end up using it. But at least have a go at this method, and then that way you can make an informed decision. Yeah, actually I like this way better, or no, I'm going to stick with the way I'm used to doing it. Like, just because I do it this way doesn't mean you have to. If you already know how to solve these and you're comfortable with your method, by all means stick with it. I'm just showing you an alternative way of doing it that you might end up preferring. Okay, so exercise 1C.